A uniform plank AB of weight 100 newtons and length 4 meters rests in equilibrium with the end A on rough horizontal ground. So we can mark the vertical weight 100 newtons at the midpoint G of AB. We will have a normal reaction RA to the floor and a frictional force FA. It rests on a smooth cylindrical drum. It's fixed to the ground, it can't move. We're told that the plank is at alpha to the horizontal. So we can mark in the normal reaction to the cylinder. This is the important thing to remember with cylinders, that the reaction acts along a normal which is at right angles to the plank. And as the plank is at an angle of alpha, the reaction RC will be an angle of alpha to the vertical. We're told that sine alpha equals 1/3, so we draw a right angled triangle with a height 1 and a hypotenuse 3, so that the sine of the alpha would be 1/3. We calculate the missing side using Pythagoras, so the square root of 9 minus 1 is the square root of 8, which is 2√2. And from this we can read the cosine as well as the sine of alpha. We're asked to calculate the least possible value of the coefficient of friction between the plank and the horizontal floor, given that the plank doesn't slip. We know that the least possible value of mu will be FA divided by RA. So we need to calculate the various missing forces. We're going to start by taking moments about A to calculate RC. So the moment of RC about A will be 3, the perpendicular distance, times RC. The moment of the weight, 100 newtons, about A will be the distance AG, which is 2, times cos alpha to give us the perpendicular distance between A and the force 100 newtons. From this we can see that RC equals 400√2/9. We're going to resolve horizontally to find FA, and FA will equal RC sine alpha. So FA will equal 1/3 of 400√2/9, which is 400√2/27. We resolve vertically and we find RA will be 100 minus RC cos alpha, and we substitute 2√2/3 for cos alpha and 400√2/9 for RC, to give us RA equals 100 minus 1600/27, so RA equals 1100/27. So mu must be greater than or equal to FA over RA. We substitute FA and RA and we get 4√2/11, and that equals 0.514. So this must be the least possible value of mu.